Let me do a tutorial to solve a function using Lagrange Mean Value Theorem. Example: verify f of x equals to 1 plus x squared in 1, 3. Solution: the function f of x is a real valued function in the limits 1, 3. 1, 3 are the limits a, b, where a equals to 1 and b equals to 3. So the very first thing that I'm going to do here is to check that whether the function satisfies the two conditions or not. Condition number 1 is that function f of x is continuous in limit a, b. So look at here, the function f of x, which is 1 plus x squared, is continuous or not. Yes, it is a continuous function because it is polynomial. Since the function is polynomial, therefore it is a continuous function. Polynomial expression always has variables with a power. If the function is non-polynomial, then it is a discontinuous function. Condition 2 says that whether the function f of x is differentiable or not. Check the function 1 plus x squared. Can we differentiate this function? Yes. After differentiation, it equals to 2x. So this function f of x satisfies both the conditions. Now I can proceed it further. From the equation of the Lagrange Mean Value Theorem, which is f prime of c equals to f of b minus f of a, or b minus a, where a equals to 1 and b equals to 3. But f of a, f of b, and f prime of c are unknown. They need to be calculated. Take the function f of x, 1 plus x squared, and substitute the value of x equals to a, where the value of a is 1 here. This is the value of f of a, which is 2. Again, take the same function f of x equals to 1 plus x squared. Substitute the value of x equals to b. The value of b is 3 here. So this is my f of b, which is 10. Now take the function f of x equals to 1 plus x squared again. Take its derivative, f prime of x equals to 2x. Substitute the value of x equals to c, and this is my f prime of c, which is 2c. Now substitute the values of f of a, f of b, and f of prime of c, which are 2c equals to 10 minus 2, or 3 minus 1. Going back to the graph, where f of b is 10, f of a is 2, b is 3, a is 1, and f prime of c is 2c. So I have all the values for this equation. This 2c is the value of point c, where the right side of the equation is actually the slope p of q. Let me solve this equation further, and I have the value of c equals to 2. This is the value of c, which is 2 here. Now look at here, does 2 exist between 1 and 3? Yes, it occurs within the limit 1 and 3. Yeah, the point c shouldn't be less than 1 and shouldn't be greater than 3. 2 lies between 1 and 3, and 1 and 3 are the limits a and b. Hence this theorem is verified.